Welcome, ladies and gentlemen. We are going to look at a video on absolute value equations, and things to keep in mind would be that you are looking at equations, okay? So you need to still remember your inverse operations for life, club, you're working backwards. Keep that in mind before we begin. You are trying to find out what the variable could be to make the solution true. And remember absolute value, this is the distance, and number is from 0. Number is from 0. Okay, so keep those things in mind. If you need to go back to old notes or old content before we start, please do so. So, one-step absolute value equations. We're going to start with just one step first. Please remember that the absolute value is a distance and number is from 0. And very important, absolute value can never be negative. Okay, it's always a positive. So if I said the number 3, how far is it from 0? It's 3 units. Just like negative 3 is also 3 units from 0. So what that would show is the absolute value of 3 is 3, and the absolute value of negative 3 is also 3. Here are your steps. So take a minute and pause, please do that, and write down what the steps to solve an absolute value equation are. Okay? So when we did expressions, we didn't remove the symbols. When we do equations, we're going to remove the absolute value symbols, and we're actually going to rewrite 2 equations, one with a positive answer and one with a negative answer. The reason we do this is because inside here, if you look at this first one, it's t plus 6 is equal to 4. The absolute value of that is 4. So that means that inside here we could end up with negative 4, absolute value of that is equal to 4, or the absolute value of 4 is equal to 4 as well. So that means that inside of there, this part could be either negative 4 or 4. So that's why we write 2 equations. So we set it up. T plus 6 is equal to 4, and t plus 6 could be equal to a negative 4. So you do one positive, one negative. Then you evaluate the 2 answers. So you solve, you're going to have one solution for each. And then your answers should be in brackets like this. So using those steps, we're going to try this. So we're going to do our train checks for both. T plus 6 is equal to 4, so we undo inverse operation by subtracting 6 on both sides. And we get that t is equal to a negative 2. And subtract 6 on this side. T is equal to, add the opposite, a negative 10. So in brackets, my solution would be negative 2, 10. Bracket. For the negative side, negative 10. So graphing this just looks like, I'm going to put my 0 here, negative 2, 3, 4, 5, 6, 7, 8, 9, 10. Just looks like the solution would be here and here. Those are the 2 numbers that work for this solution. So notice we can't use parentheses because then it would look like a ordered pair. We want it to be those brackets so that we can tell it's a solution for this absolute value equation. So this next one, I'm going to write 2 equations. One, removing the absolute value symbols to a positive, and then one without the absolute value to the negative, because I know that the absolute value of 1 is 1, and the absolute value of negative 1 is also 1. Do my train tracks. Inverse operations, just add 3. C is equal to 4. Over here, add 3. Negative 1 plus 3 is 2. So my solution in brackets is 2, 4. Least to greatest. And so I plug in a 2 and a 4, and those are the two possible solutions for that absolute value inequality. Equation, excuse me. 2 more. You can pause and try them and then press play and see how you did. So I'm going to write 2 equations without absolute value, 1 positive answer, 1 negative answer. I'm going to subtract 2 from both sides. And then I'm going to get n is equal to a negative 1, n is equal to a negative 3. So my solution, negative 3, negative 1. And on here, negative 1 and negative 3. Remember, you can plug them back in and check, which would be actually a great thing to do. If you plug them in with the absolute value, you need to make sure that your solution is correct, and if it is, then you're good. So over here, w plus 1 is equal to 5, and w plus 1 could also equal negative 5. So we solve each equation for w equals 4, and w equals a negative 6. So my solution set is negative 6, 4. So I have a negative 6, 0, and 4. Those are the numbers that work. So one thing here to think about is it possible to have an absolute value equation equal to a negative number? Just think about it. Could that be possible? Is this a thing that can happen? If we know already from the rule above, absolute value is always greater or equal to 0. It's never going to be less than 0. It's never going to be 0 is 0 units away from 0. Negatives are still a positive distance from 0 because distance we measure in a positive. Absolute value is never negative. So this, what happens here, is that there's no solution. Okay, so when you have it equal to a negative already before you take away absolute value, it is no solution because absolute value is always positive. All right, multi-step absolute value equations. So it's a little key concept here to look at. When solving equations that involve absolute values, there are 2 cases to consider. So again, we already talked about this. That case 1 is that it's going to be positive. Case 2 is that it's negative. This is just another book example. I'm going to kind of fly through this. It's going to be one or the other. So again, the steps are here. So if you didn't record them, maybe ask your substitute to pause it now if you need to and get those written down again. Otherwise, we're just going into multi-step. So not much different. We're still doing inverse operations, and we're still writing 2 equations, one with a positive answer and one with a negative. So let's try this first one. Removing the absolute value, 6m minus 3 is equal to a positive 9, as well as 6m minus 3 is equal to a negative 9. So we do our tracks. Now, working backwards. So m was multiplied by 6, then we took away 3. So we undo and we add 3. And I bring down my 6m is equal to 12. Divide by 6. I get m is equal to 2. Same thing over here. My operations are going to be the same, but my answer on the right is going to be different. So I still add the 3 back. Bring down my 6m. Now over here I have a negative 6. Divide by 6. M is equal to a negative 1. So then my solution is negative 1, 2. And in brackets, it'll be negative 1, 2. looking at this one, some of you are going to go, okay, I'm going to do this really quickly and set this up. And then I'm going to set up one to a negative and one to a positive. But then I think, sure, you're going to get answers if you do this. If I do this really quickly, you don't have to copy me here on this step. I get n equals 1, and over here, I get 3n equals 5. Divide by 3, I get n equals 5 over 3. If I plug both these in, they're not going to work. This is where checking your solution matters. So I get 3 times 1 minus 4 is equal to negative 1. I get absolute value of negative 1 is equal to negative 1, but the absolute value of negative 1 is 1. And negative 1 is not equal to 1, so this would be a no solution because I can't have absolute value equal to a negative. So without all that work, I could have just said that and written no solution. Couple more with an added step. These ones look a little bit different. You'll notice that there's something in addition to the absolute value. So what I want you to do is make sure you go back and I guess add this first one. I should have said that before. This first step matters in this now that they're multiple step. What we need to do is isolate the absolute value portion to one side of the equation. Okay, so make sure you have that down, and then we go and we can remove the absolute value. So on here, I have this plus 3 attached. So it's the absolute value of this plus 3 gives me 6. So we want to find out what the absolute value was before. So we have to move the 3 first. Then we have 2x minus 1. Absolute value of that is equal to 3. Then we're able to set up our two equations. That's equal to the positive and one that's equal to the negative and solve those. Now we're a regular two-step equation again, and we should feel fairly comfortable. So we add 1, we get 2x equals 4. Add 1, 2x equals negative 2. Some of you might want to go like this and solve both at the same time. That's fine. Just make sure you're keeping organized. So then my solution for this one, it's terrible, is negative 1, 2. And again, check them. One more, you can give it a try. Remember to isolate the absolute value first. So this is really the absolute value of 3x minus 6 is equal to 6. Then write your two equations. And solve one for the positive. And solve the other one for the negative. Remember, 0 divided by any number is 0. So my solution here is 0, 4. All right. Last time you're going to get the opportunity to write down these steps. Write them down, and you can try these 4. I'm going to put them up on here, and then we'll try them when I get back, and we'll check our answers done. Make sure you are good, and you do your best. This video is linked to Moodle so that you have it for future reference. Don't forget, isolate absolute value, remove the absolute value symbols, rewrite two equations, one with a positive, one with negative, solve both using inverse operations, put your two possible solutions into brackets, or write no solution. When you're ready, remember that these should be in parentheses eventually, so then you'd be distributing. Good luck!